Hello everyone, this video explains the overview of 2D physics. Developers need to upgrade the Layer IDE to version 3.1 or above. First, let's understand the general concepts of physics. In game engines, physics is a system that simulates the motion behavior of objects in reality. 2D physics creates realistic physical reactions in two-dimensional space by simulating the physical laws of the real world, endowing objects in 2D games with realistic behavior and interactivity. With a physical system, the gaming experience will be richer and more realistic. For 2D games, it can enhance immersion and realism, provide richer interactivity, broaden game types, and reduce work barriers. Next, we will learn to use the physics module in Layer IDE. First, open the project settings. Check the engine module Physics 2D. Then select the Physics 2D module. Layer has built-in support for the Box 2D Physics Engine 2.4.1 version. Box 2D is the JS version. Below is the WASM version of Box 2D. And the third is the custom 2D physics module. In the project settings, there are global settings related to Physics 2D. For intuitive expression, developers need to note that we default to converting one length unit in the physics engine to 50 rendering pixels. In addition, the setting of the length unit conversion ratio is open in the project settings, and developers can adjust it independently according to the actual needs of the project. Other global settings will be explained to you in the corresponding components. Below, we will introduce the learning plan for this series of videos. First, let me introduce to you the rigid body. The rigid body is a mechanical expression model that can reflect the physical characteristics of an object. Generally, objects using 2D physics need to add this component so that the object can obtain gravity and accept force. Next is the collision body, which is a shape component used to detect collisions. If there is only a rigid body without the shape area of the collision body, the collision effect cannot be generated. Therefore, when using a collision body component but not adding a rigid body, the rigid body component will be forcibly added. The content of the collision body is extensive and divided into two parts. The first part is the collider base. This part explains some common properties of the collision body. The second part is the collider components, including circle collider, box collider, polygon collider, edge collider, chain collider. The 5 colliders have some common properties, which will be explained in the previous section class collider base. Joints are used to simulate various physical connections and constraints between objects, such as springs, marionettes, pendulums, etc. Joints can be used to define how objects are connected together in a specific way. The visualization operations just introduced are all performed in Layer IDE. In the script code, some event methods can be triggered when objects collide. Among them, 2D physics can only trigger the trigger type events, while collision type events can only be triggered by 3D physics. 3D physics will be introduced to you in another series of videos. Besides the popular Box 2D, developers can also customize other Physics 2D module. The last video content introduces how to use custom Physics 2D module and compares them with the built-in Box 2D in Layer IDE. The above is all the content of the tutorial. Let me summarize it for you. This series of videos is divided into these parts. Currently, we are studying the overview of 2D physics. Later, we will learn rigid body, collider base, collider components, joint, physical events in components, customize physics 2D module. The collider will be demonstrated in 2 parts. All of these knowledge points will be explained in detail for everyone. This video ends here. Thank you everyone.